Hello and welcome to the OCR Further Maths videos for Pure Core. This is Calculus 5, Volumes of Revolution and Mean of a Function. And this video 5.3 is rotation about the y-axis. So we've looked previously about what happens when we rotate around the x-axis. When we rotate around the y-axis by 360 degrees, again a solid is formed. We want to be able to find the volume of revolution for that solid. So in this picture here we can see that this curve f of x here has been rotated around the y-axis between C and D, and we get this solid here. Again, what we're going to do is take cylinders with an ever decreasing height and sum them together, and that's how we find the volume of revolution. So delta y, the small value of y there. So the volume of that disk is pi x squared delta y, because x here is the radius of that cylinder. So the total volume is given by the integral between c and d of pi x squared dy. So you can see it's very similar to when we do it around the x-axis. In this case, the difference is that we carry it out with respect to y, because we're rotating around the y-axis rather than x, and that the limits of the integration are the y-coordinates rather than the x-coordinates. These two things are very important, and that's where it's very easy to make mistakes in this. So make sure you're really clear which axis you're rotating around, and therefore what you need to integrate with respect to and which coordinates you need to use. So here's an example. We have this region here, which is bounded by the curve y equals 2x to the half and the y values 2 and 4. And it's going to be rotated 360 degrees around the y-axis to find a volume. So the volume is the integral of pi times x squared dy. Now we can see here that we've got the curve y equals 2x to the half, so we're first of all going to need to rearrange that so we've got x as the subject of the formula. So when we do that, we get y squared over 4. So the volume is pi between 2 and 4 y squared over 4 all squared with respect to y. So that's pi times the integral between 2 and 4, y to the 4 over 16. And so when we do that integration, we get y to the 5 over 80 between 2 and 4. And when we work that out, we get that it's 64 over 2 pi. So you can see here that the actual integration has been fairly straightforward. What's important is that you remember that you need x in terms of y, you need to integrate with respect to y, and that these limits here, c and d, are in fact on the y-axis, not the x-axis. Okay, so now we're going to have a look at this example. We've got a region bounded by the curve y equals x squared minus 3, the y-axis, and the lines y equals 4 and y equals 5, and it's rotated 360 degrees about the y-axis. Which of these is the correct calculation to find the volume of revolution? So pause the video, have a little look, and we will go through them. Okay, so if we have a look here at the first one, the error we've made there is that we're integrating in x, not in y. We're being rotated around the y-axis, so we need our integral to be in terms of y. If we look down here at this one, we've forgotten our pi. And if we look at the bottom one, you can see here we're integrating with respect to x, not dy. Now this is a really common problem because people might just ignore that dx and do the integration anyway, but this is not correct notation. You need to be integrating with respect to y. So this one is the correct one, because we can see that when we rearrange this equation, y equals x squared minus 3, we get x squared equals y plus 3. As we're going to be integrating x squared, we can leave it like this. We don't need to find out what x is. We want to know what x squared is. Okay, so the next video will be 5.4, curves defined parametrically.